In this video, we're going to talk about different types of data. Okay, so there's two main breakdowns for different types of data. There are qualitative data and quantitative data. All right, so qualitative data is categorical type data. So data that can be put into categories. You can think of maybe what's your favorite color. People will answer red, yellow, blue. These are categories of color, right? So usually qualitative type data is not numeric. However, qualitative data may be numeric. For example, if you were to think about zip code. Okay, now your zip code puts you into a category for where you live. All right, so that would be a qualitative type data. All right, then we have quantitative type data, and this is numerical data that can be ranked. Okay, so numerical data that can be ranked. So zip code is numerical data, right, your zip code, but it is not rankable in the sense that if you have one zip code, it doesn't make you better than someone who has a different zip code, or it doesn't really mean much other than you don't live where that other person lives, right? So quantitative data, it must be numeric and rankable. Okay, then once you have different types of quantitative data, once you've decided you're quantitative, there's two different breakdowns from quantitative data. So there's discrete data, which is countable, and then continuous data, which can be any value. All right, so for example, in discrete countable, maybe I don't know, like the number of hairs on your head, right? Everyone has a different number of hairs on their head, and so but you could count them theoretically, right? So there could be several thousand, or I don't even know, million hairs on your head, right? And you could count them, but there's never going to be a half of a hair, right? It's going to be, there's going to be someone has 10,000 hairs on their head. It's not going to be 10,000.1 hairs on their head. No. So that is a discrete and countable type of data. All right. Continuous. This can be any value. You could think of maybe your weight, right? So your weight, that's numerical data that can be ranked, because someone who weighs 90 pounds weighs less than someone who weighs 200 pounds, right? So that's rankable type data. And it can be any value in the sense that we can measure weight to more and more precision, right? So using a crude scale, we'll see that they weigh 140.2, right? But then using a better scale, we'll realize they weigh 140.25316.8, and we can always get more and more precision to their weight. So that is a continuous type of data. All right, so now let's go ahead and do several examples where we need to identify the type of data. So starting with gender. So gender. So that's going to be male, female. Maybe there'll be a third option for another type of gender. But gender is going to be a category. So since it's a category, it will be a qualitative type of data. Right? And then from qualitative, there's no further breakdown, so we just leave it there. It's qualitative. Now your age in years. Right? So if we were to ask everyone how old they are and the number of years, they'll give us numbers like 18, 13, 17, right? They'll be countable type numbers. If we ask them to give us the age in years, they shouldn't really be giving us their age as 13.1 or something like that. They should tell us that they're 13, right? So this is numerical data that can be ranked, right? Someone who's 10 is younger than someone who's 13. So because it's rankable numerical data, that makes it quantitative. And then because it's countable, that's going to make it discrete. So quantitative and discrete. Next, height. Okay, height is numeric type data. And it can be ranked, right? Someone who's 5 feet is shorter than someone who is 6 feet. So because it's rankable, rankable numeric data, that makes it quantitative. And let's see, is it going to be discrete or continuous? Well, we can always measure height to more and more precision, right, with better and better instruments. So that is going to make this continuous, right? So with one instrument, they may be 6 feet 2 inches. And then we can say, oh, but they're actually 6 feet 2.5 inches. Oh, actually they're 6 feet 2.54321 inches, right? And we can get that more and more precise. So that's what makes this continuous type data. Okay, moving on to uniform number. Okay, uniform number. This is numeric data, right, which makes you want to think it's quantitative. But hold on, can it be ranked? Is someone who is number 1 better than someone who is number 10 on the field? Not necessarily, right? So your uniform number is usually just your favorite number or a number that was assigned to you by your coach. Is nothing to do with your ability to play or anything like that. So this is a qualitative type of data. Qualitative type data. And then once you've determined it's qualitative, there's no further breakdown from there. Okay, lastly, temperature. Now, temperature, let's see, that's numeric. Okay, so that makes you say quantitative. Can it be ranked? Well, let's see, yeah, because 30 degrees is definitely colder than 60 degrees, right? So it is quantitative. All right, so it is quantitative. Now, from quantitative, what else is it? Discrete or continuous? Well, let's see. Can we measure temperature to more and more precision? Yes, of course we can, right? It can be 32 degrees Fahrenheit, and then with a better instrument, we'll see, oh, actually it's 32.5 degrees Fahrenheit. It's 32.4983 degrees Fahrenheit. We can, with better and better instruments, we can measure temperature to more and more precision. So that makes this quantitative and continuous.